Welcome to our next panel on CCS and the cement industry. And I'm delighted to have a diverse panel of experts to discuss the question, where are we and what's needed for net zero? So our first panelist is Guloren Turan of the Global CCS Institute. And she has global responsibility for advocacy, including international climate policy activities focused on the UNFCCC. Previously, she worked for the Trans-Adriatic Pipeline and BG Group. Guloren holds a master's degree in public administration from Harvard, an MBA from Cornell, and a BSc in industrial engineering. So Guloren, welcome. And can I ask you for your views on where we are, what's needed for net zero, and generally the outlook for CCS?
Thank you very much, Ian. Good day, everybody. And thank you very much to the World Cement Association for inviting me to attend this major event. Now is truly an exciting time for CCS. And just a week ago, we as the Institute released our annual flagship report, The Global Status of CCS. And the report shows that in 2021, the global CCS facility continued to grow for the fourth year in a row, increasing by almost a third year on year. In the first 9 months of 2021 alone, we added 70 new commercial facilities to our database, bringing the total number of facilities in what we call the CCS database or the CCS facility pipeline to 135. Now, to be clear, 27 of these facilities are currently operating. There are 4 under construction, and the remainder are in various different stages of development. When we take a step back and look at the drivers behind CCS momentum that we've been observing in the past few years, I think undoubtedly the key driver is the adoption of more ambitious climate targets and increased climate action, both from governments and private sector. Net zero commitments now there are more than 100 countries with net zero targets and thousands of companies with net zero, again, kind of ambitions. And this has driven the point home about the necessity of CCS in order to deeply decarbonize. And this has created a virtuous cycle in the sense that governments are responding by putting in place supportive policies, more supportive policies for CCS. The private sector, seeing a strengthening business case for CCS, is stepping up its action and it's advancing new projects and developing new business models, more suitable business models to both reduce cost and risk. And with that, I particularly mean what we call CCS networks. These are hub and clusters. And of course, the role of CCS in supporting both the production of low carbon hydrogen, which then can further be used to decarbonize industry and transport, but also for carbon removal, direct carbon removal from the atmosphere, is proving to be important drivers for the acceleration of CCS. Now, CCS is a very important option for the world's heavy industry, for some industrial sectors, such as, of course, cement, but iron and steel and chemicals, which are sometimes referred to as hard to abate sectors. These sectors cannot basically make their products at the moment without producing CO2. And yes, it's possible to switch to renewable energy or increase efficiency, but these are not able to solve the problem at a large scale. They can, of course, reduce the emissions, but in order to deeply decarbonize these sectors, CCS is an available sort of large-scale solution that we have at the moment. The global cement sector, which I believe emits around some 4 billion tons, roughly maybe 7 or 8% of global CO2 emissions today, is obviously got a considerable abatement challenge. And again, as discussed, it's possible to use different options, which I'm sure are being discussed throughout the conference, such as efficiency, such as kind of different electricity use, low carbon electricity use, etc. The main challenge, of course, is the fact that CO2 emissions come from the process itself, from calcination of limestone, which I believe account for roughly 2/3 of the emissions related to cement production. Now, when we look at how CCS may be applied, There are, of course, two ways: post-combustion, what's called post-combustion CCS, and this approach is being currently deployed at Heidelberg Cement's Norcem Brevik plant in Norway, which is under construction to capture and store around 0.4 million tons of CO2, 400,000 tons of CO2 per year. And Heidelberg Cement is also developing, as announced rather, a larger facility in Sweden that is going to capture and store around 1.8 million tons of CO2 per year, a large number. And this will be significant, of course, not only for its scale, which is, as I said, huge, but also for the ambition to create the world's first carbon neutral cement factory. Now, of course, an alternative CCS pathway for the cement industry is to separate the calcination CO2 by heating the raw feedstock and keeping it separate. This is seen in the Leilac facility in Belgium, which of course incorporates Calix's technology, and I'm sure we'll hear more from Daniel about it, also of course Eberhart as well, about the technologies, the various different technology options when it comes to CCS. So in a nutshell, I think whilst the progress over the past 4 years is very encouraging, it's nowhere near enough globally when we look at CCS. We at the Institute, at the Global CCS Institute, calculate that if we're to meet our climate targets, i.e., for example, the IEA's Sustainable Development Scenario, the capacity, CCS global capacity, has to increase by a factor of 100-fold over the next 30 years. So obviously this is challenging, but we believe that it can be done, and we've known that this has been done in different industries in the past, but it does require government and businesses to work hand in hand, governments to put in place supportive policies to enable robust business models, and the private sector to step up, invest, build, and operate. And I think, thankfully, we're starting to see this happen, hence this sort of momentum in the CCS facility pipeline. But given where we are with climate, given the urgency of the issue, I think we have no time to lose. And I think I'll stop there.
Thank you, Guloren. That was an excellent introduction. And thank you for your segue over to Daniel. So my next guest, the next panelist is Daniel Rennie of Calix. Daniel joined Calix in 2014 to develop and coordinate the Leilac projects that Guloren was just mentioning. Daniel previously had helped establish the Global Carbon Capture and Storage Institute in Europe and managed the European Commission's CCS demonstration project network. Daniel, following on from what Guloren said there, can you give us your view on where we are and what's needed?
Absolutely, and thank you very much, and thank you for Guloren for giving such a good introduction, actually, to quite what's happening within the field of lilac, which I'll talk about a bit briefly before talking about more generally about what is required. As Guloren was saying, that the cement sector is a hard-to-abate sector due to the process emissions, and it's really due to processing limestone, of course, which almost releases half of its weight as CO2, and there really is very difficult to get away from that. And so the lilac projects and the technology behind it is very much, in fact, solely focused on those unavoidable process CO2 emissions. And it's a new type of carbon capture technology that works within the existing cement plant process. So it is about, as we've heard, heating that limestone and effectively ensuring that the released CO2 from the limestone isn't contaminated, so that it really is just separated and kept clean. Effectively, the lilac process works by having these steel tubes which keep the flue gases and air separate from that CO2 released from the limestone. And in theory, it doesn't require any additional energy or processes or chemicals compared to the conventional cement plant to keep this process CO2 pure. Because it just needs to heat these steel tubes, it can use any energy source or heating source. So certainly electricity and hydrogen is just a way of enabling that, decarbonizing that section. But also from those flue gases using conventional fuels or even alternative fuels, it can use those. And then the synergies with conventional or any other carbon capture technology become very strong, because a lilac system and then with an additional smaller carbon capture system to capture those flue gas emissions could be a very effective and quick way to get to zero and negative CO2 emissions. It was interesting, in some of the earlier sessions we were talking about cooperation between companies, and the Lilac project is a really good example of such cooperation. It is not a Calix project, it's actually a collaboration between Heidelberg Cement, Cemex, Zimpor, Loast, and a whole range of others to really see if this could be applied as a technology. And we were very fortunate to receive European funds in 2015 to see if it could be applied. So we built the Lilac 1 project on time and on budget in 2019, and that's capturing about 5% of a cement plant CO2 emissions. And we've, again, been very fortunate as a consortium to receive more European funding to scale that up. And next year, we should be constructing at Heidelberg Cement plant in Hanover, a plant capturing about 20% of a typical cement plant's total emissions, about 100,000 tons per annum of CO2. So we're through collaboration, we're actively trying to develop this, and all other technologies do need to be developed hard and quickly. But last week, we released the Lilac roadmap. That is about how we intend to roll this out as well, and giving an overview of the costs. But the intent, as has been repeatedly stated, is to really enable the cement industry at large and globally to decarbonize. And so the intent with this technology is to be a small modular blueprinted technology that local cement engineering companies can actually use in the coming decades to enable global decarbonization. So a very, very exciting time to be here and talk about this, but really looking forward to the discussions. But the big finding from the roadmap was that technologically there are lots of options for decarbonisation. But it does need to be a joint effort with government and society to actually enable these technologies to be actually deployed at scale in the scale required over the coming decades. And that's the real call for cross-societal collaboration. But hopefully talk about a bit more about that.
Thank you very much, Daniel. Can I just ask you to clarify one thing? In this Hanover project, what are you intending to do with the 20% of the CO2 that's captured?
That's a very good question. At the moment, the project is really just about proving that it can be applied and integrated into a cement plant. And we've actually got specific work streams looking at all of the different options to actually help inform the cement industry about what the options are. And this can be everything from at a small scale, sales for the CO2, sales of the CO2 for food or fuels or actual bespoke uses like that. Looking at also the prospect of mineralization, using that CO2 within building products, but also looking at CO2 sequestration and the range of options available there, and actually doing this from a cement perspective rather than CCS has been around for decades. It's a well-proven full chain technology, but it's been very much focused on the oil and gas sector and the power sector and decarbonising huge industry. The cement sector is ironically quite small on a per plant basis, and so it's really having a very cement focused lens on quite what that will be. So it's very much part of the project.
Thank you. So Eberhart, if I could come to you next. So Eberhart Wusterhaus Gomez is our next panelist, and he is the commercial director for Carbon Clean. He has 15 years of experience in environmental services globally. And prior to joining Carbon Clean, he worked with the Weissman Group. He has a degree in mechanical engineering and mechatronics. So Eberhart, what's your view of the current situation and what's needed for net zero?
Thank you, Ian, also for this invitation and for the introduction of my person. Basically, it's very interesting, the topics that has been presented by Guloren and Daniel. And I believe, that our philosophy as Carbon Clean is pretty much aligned into this, but also a little bit more flexible and extended into how can we, in the shortest time, be able to motivate those industries that are hard to abate, as also Guloren mentioned. How can we bring them into this new sector of carbon capture and either utilization or storage? So we understand that these industries, they have assets that they have a different, they have a long life cycle. We're talking about 30 to 50 years in the heavy industry. And we need solutions that can be retrofitted, that can be then adapted to different opportunities and also to mindsets in the industry and in the public sector. So when we think about the heavy industry, it's very well known that it needs to have a feasibility, the technology, and has to be able to provide an economy that will allow them to be still competitive in all the geographies. So the biggest challenge that we see is how can we come from what it is now to 2040 to 2050 in terms of a net zero industry. And that is where we see the most interesting solution, which is, of course, the one that applies Carbon Clean, in getting into a long journey of capturing CO2 as per the demand or as per the infrastructure there's been, but also motivate the industry to see ways that they can actually create revenues out of this. It is very important to understand the mentality of the industry, and we cannot just penalize through a carbon tax. We also need to see CO2 as a commodity, as a feedstock that can be then also offset other type of fuels or chemicals and materials that comes from the fossil fuel sector. And that is, I think, part of the success of Carbon Clean, that we are providing a transition technology that also is evolving through the years. How can we make it more compact? How can we provide a solution that makes it much more simpler to install? And at the same time, look into the geographies and understand if it's possible to store them or it's better to utilize at this stage. Because as Guloren mentioned, we have no time anymore. We need to start acting now. And if we start waiting that infrastructures for CCS is available, or if we start waiting till legislations are there to motivate the industry through this way, I believe that then we will have a big problem in the next 5 to 10 years. And also very, very important to understand is the demand that we're going to be having in terms of this type of technologies is something that is very is well underestimated, in sense that, okay, I see that these companies will have this new technology by 2025. But the most important thing is when I'm going to get that technology and be able to implement this. When we see the whole structure of the heavy industry and the amount of assets that they have, plus the amount of units they will need through the next 10 to 20 years, there's a big issue in terms of how we're going to be able to supply that demand. And even looking at it from a global perspective, all the technologies that are available, I still see a big constraint if everyone will just wait until 2025 or 2030 to implement their strategies. So what we promote as well is to go through this journey now, understand what capacities are the most suitable for them, depending also in terms of their budgets, their legislations on site, and the business opportunities that they can find. But motivate the industry for us is the key challenge. And the way that we're solving this is going through an evolution with our technology and showing them from a perspective of a very mature technology what they can do, and then the next generation technology that will make it a footprint much smaller. We're going to be able to decrease considerably the cost of carbon capture. We expect that will be around 1/3 of what currently we are experiencing with the conventional technologies, and this way to create a rollout for the next 20 to 30 years.
Thank you very much, Eberhard. That was very clear. We have one question from the audience so far, and we'll come to that in just a minute. But I'd like to ask the three of you a slightly more macro question first. So one of the constraints, or one of the things that we need to get right in terms of applying CCS to the cement industry is the economics. And I think the projects to date have all received a great deal of subsidy. So I'm curious as to how you see costs changing over time, and at what stage are we going to get to the situation where the cost of carbon in the ETS or other trading schemes or carbon taxes is sufficient on its own to make the projects viable? And then I'm also interested in whether or not that has implications for the structure of the cement industry. So whether or not the solutions, the decarbonizing solutions, are going to favor particular plants, for example, very large plants or perhaps very small plants that are close to markets where CCU might be an option, or plants that are in industrial hubs or so on. So maybe I could put that sort of suite of questions regarding the economics to you. And Guloren, I'll ask all of you this question, but perhaps Guloren, you'd like to kick off on that.
I could, thanks, Ian, and I'll give a broader perspective on the costs of CCS before handing over to my fellow panelists who are more on the cement industry specific cost issues. But we certainly are seeing and anticipating to see costs of CCS as it's applied to, excuse me, a number of different sectors, as we've discussed, kind of come down over the years. In fact, we've been observing that already. I've got examples, for example, from the power plants that have CCS on them. The first power plant was Wonder Dam in Canada, capture cost of around above $100 a ton. The second one, Petronova, kind of came down to around $65 a ton. And now when we look at the kind of number of plants in the pipeline, the estimated costs of capture are around $45 to $50 a ton. So from the first of a kind to second of a kind and to the nth of a kind, we're seeing sort of significant costs.
Guloren, could I just clarify that? Is that just the capture, or does it include the transport and storage as well?
This is just the capture. This is just the capture. Okay. And the reason, of course, for that is, first of a kind project. It's gold plated, not off the shelf. As we sort of see, as I said, a second of a kind or the nth of a kind, we'll get economies of scale. We'll get learning by doing effects, where we kind of learn how to do things better. It's going to be more off-the-shelf facilities. And also, I think the risk premium that the finance sector applies to these projects is going to come down. So we'll see the cost of capital probably come down as well. So I think overall, we're expecting to see costs of CCS come down across the range of industries that we're looking at significantly. And when we talk about the cost of cost of carbon, for example, in Europe, obviously in EU ETS, it used to be 5-10 euros a ton, to now we're at $60 to $65 a ton, euros. And that sort of in itself makes a lot of the mitigation options, increasingly more competitive. I think the challenge will be to bridge that gap between cost of doing CCS and then the cost of innovation coming down whilst the cost of carbon is going up. And I think that's the sort of the intermediary challenge that we have. And that's where I think policies need to come in to support application of CCS on industry.
Okay, so you can see a point at which it could become viable without subsidy to invest in CCS.
Yes, certainly. And when we talk about subsidy, I think there are different ways, obviously, of looking at it, Ian. For example, contracts for difference is being considered in Europe, whereby that's how the gap between the current carbon price and the cost of capturing and storing can be kind of can be alleviated. So there are different ways of doing it. I think subsidy is a broad term, but different ways of encouraging or supporting the economics of deployment.
Okay, thank you. Daniel.
Well, I suppose I'm very fortunate in that that the lilac technology is in theory quite cheap. So when we're talking about large subventions, with the Lilac 1 pilot, about 5%, that cost about €7 million. Lilac 2 should cost about 16 million euros for CapEx. And we do have a number of technological developments that are required, and we do need to prove integration. But as we released in the Lilac roadmap, for an nth of a kind developed application, we're expecting costs to be around 25 euros a ton. And that's for abatement cost, including CapEx, including OpEx and all depreciation and compression costs. And hopefully we'll do something approaching that with Lilac 2 in Germany. But it really is, in these early moving projects in the coming years, it is about risk. So that is significantly under the ETS price at the moment, but the risk to the cement plant that needs to be fully operational is the key consideration. And then it really becomes quite a question of transport and storage. And so you were talking about those I suppose, enabling factors, and that the cement industry produces clinker. It does produce CO2, and it is something it will need to deal with. And I think Eberhart and Guloren really articulated that very well. But if we are trying to decarbonize and ensuring that CO2 does not reach the atmosphere at global scale, we're talking gigatons of CO2 that needs to be stored, and annually. The cement sector can't necessarily do that alone, and actually having that transport and storage infrastructure there and actually in place and at a scale of the current oil and gas network really would enable the industry to decarbonize. And I think North America is a great example of this. In the 1970s, the US government funded 4,000 miles of CO2 pipelines to enable EOR. That's enabled all of as Guloren was mentioning, all of these CO2 projects to really take off. And if that CO2 infrastructure is in place, then it becomes significantly easier to tie into that rather than having to do point-to-point projects. But also having the flexibility, because the cement industry is so dispersed, to actually also enable very small-scale point-to-point projects to be enabled as well. So it needs to be a really diverse pitch and very bespoke per plant if we're going to do this in scale.
So Eberhart, can I turn to you, to get your comments on costs and economics, and in particular the question of the impact on industry structure, whether it favors particular types of plants?
Absolutely, Ian. I think that I really concede with Daniel and with Guloren about the economies and how the evolution of the technologies will allow and motivate the industries to adopt these technologies. However, the economies are very, very strongly related to the geographies, right? I mean, what is the cost of energy? What is the cost of manpower for the construction of these units? And also even legislations in place for health and safety. Our aim is very much aligned with what also Calix is doing. We're moving into the direction of the 25 euros, and we see this through our next generation technology to come through. But it's also very, very interesting, the systems that we are implementing with process integration. The heat process integration, which is a very, very common waste heat coming from the heavy industry. How can we actually take that waste heat and recycle it? Not only for the sake of the technology, but also to reduce the CO2 footprint of these carbon capture units. So in the cement sector, and working with companies like Cemex, Holcim, Tayo Cement, and other companies that we have provided those concepts, allow us to understand how deep we can go with an economy. And we see, that when there's a proper heat process integration, economies can go as low as 15 euros, 20 euros per ton with current technologies. It's just about finding the right concept and finding also the right capacity. There's a very specific understanding on what are the capacities that we need to make this feasibility that we're talking about. But it should not be the total capacity. It should be just even a fraction of it to be feasible enough for these companies to implement these technologies. And in terms of infrastructure, I think that is also a very key factor, because CCS technologies, concepts are very strong related to the geographies and also to basically governments. How are they going to implement these strategies so that the heavy industry gets adopted? So it's a very long run. We see this, of course, in Europe, Northern Europe. There's a lot of attention to CCS, but what about the other geographies going into this direction? Or what about the landlocked countries, where they are actually even thinking about liquefying the CO2, send it with a train, similar with the Northern Lights project, where you need to liquefy it and send by ship. So how all of these will work out and what economies will bring will make a very, very interesting decision to the cement companies, especially because if it's a very high price to go into carbon capture and storage, then we should be very open-minded and think about what can I do instead, and actually work with a CO2 circular carbon economy.
Yeah, thank you. So I think this point about infrastructure is a critical one. As you know, 90% of cement production is in the developing world. And, if we have good infrastructure in Europe and North America, that's only going to be addressing a small part of the problem. So that will be an additional challenge. Let's go to the questions that we have from the audience. So the first one here is from Mohammed Iftikhar, and he asks, how is the CCSU heated tube technology different than conventional CCSU? I think that's one for you, Daniel.
Yes, it's different from other technologies because this is not trying to separate gases. So normally there's an energy penalty and an additional process to separate a gas from a gas. That this lilac technology that Calix is developing, it's just ensuring that as the limestone is processed, as it's heated, the CO2 that it gives off is just kept within that tube and then taken out the top. So it's very different. It is different in that it's just not separating a gas. So it's just containing it.
Is that happening in the preheater tower, or is that?
Yes, effectively, this is a new calciner tower. So it would replace effectively the work of a modern pre-calciner where there is calcination being undertaken. That CO2 comes off at one spot, but it's mixed with all of the flue gases. This is just a way of making sure that it doesn't, very simply. Okay. So it's a...
Thank you very much. And Ronald Rajkaran asks, do we have any experience or knowledge of converting CO2 into fertilizer? I don't know, Guloren, that sounds like one for you.
Yes, in fact, that's a good question, and I should know the answer, but I'm afraid we do have experience of using CCS in the fertilizer, in the production of fertilizers, i.e., of course, kind of from capturing and storing the CO2 in a fertilizer plant. But I'm not sure about turning the CO2 into fertilizer, although I kind of suspect that it should be possible, but I need to look into it and get back to the person that's asked the question.
Okay, thank you. Thank you for that.
Maybe I can help that, Ian, about that answer. I think, the CO2 in general in the fertilizing industry has played for many, many decades a very important role. Actually, most of the sources of CO2 coming from the food and beverage come from fertilizing companies, where they are producing ammonia, and if they use the CO2, then they can convert ammonia into urea, which is also one of the main products. So in that sense, it is just basically getting that source, those feedstocks of CO2 and nitrogen, and then start producing here ammonia or urea.
Okay, thank you. We have an anonymous question. The cement industry in general are only focused on, to capture CO2 and letting somebody else take care of the transport or storage, or are they proactively focused on a complete CCUS? Eberhart, perhaps I come back to you first. What's your experience there?
We believe, that from our point of view, both concepts are very similar. It's just basically what is the end use application. So liquefaction or storage or compression and either piping it or just coming into even a critical, the supercritical point of CO2, which is widely used also in the EOR systems, somewhere around 70 bars, so that we can treat that gas as a fluid. It's basically without any vision of what is going to happen there afterwards. It's just basically conditioning a CO2 to then be able to process this in other ways and forms. That is where I see this. Mm-hmm.
I think if I could comment from a cement industry standpoint, it doesn't really do us any good just to capture the CO2. I visited the 2019 conference. We had a field trip to the Conch plant, where they have a 50,000 ton a year pilot carbon capture facility. And their problem was, after capturing the CO2, what to do with it. And of course, 50,000 tons a year at the Wuhu plant is a very tiny amount, a very tiny proportion of their total. But their challenge was that they couldn't find users for it. And so I think that the cement industry, when we're looking at this, we're not just looking at capturing it. At the end, it has to also be put into a form where it's permanently stored or permanently used. So, either storage in geological formation or usage in some product.
Correct.
May I come in there?
Yes, please go on. Yeah.
Just to add that's why, and I didn't refer to it briefly in my opening remarks, but it's why we're seeing networks, hub and clusters, CCS hub and clusters emerge as a key business model, particularly in Europe, but also in the US and other parts of the world. And with that I mean a number of capture units, capture facilities that use a shared pipeline and a storage facility, as opposed to a point-to-point, just building it from point A to point B just for one facility. And obviously that enables economies of scale, and it enables capture facilities to focus on what they do best, i.e. capture, as opposed to kind of take responsibility for the full chain. And it enables scaling up of the transport and storage infrastructure too, so we can build bigger pipelines, bigger storage facilities, and it brings down the unit cost. And I think we're increasingly seeing partnerships develop between those that are the emitters and those that want to be those businesses that are kind of expanding in the transport and storage kind of parts of the chain, oil and gas companies, EPC companies, shipping companies. So I think we're increasingly, in my view, going to see that sort of collaboration and specialization on the capture versus kind of transport and storage side of things.
May I add to that? I think that and it really will be a whole network of different options that are required for the industry. And one wonderful avenue that is being explored by cement companies is actually mineralization. So actually taking recycled concrete fines or rebinding it in building materials is part of the circular economy, and it can be classified as use in that it is using the CO2, but actually it's storage, because the CO2 is not being emitted into the atmosphere. And again, that is a really interesting avenue for exploration. It may not be able to do everything from a cement plant, but again, combined with these other sequestrations and proper use, it really will be an interesting network that the industry can explore.
And Ian, just to add, sorry, Ian, but I think that Daniel made a very interesting point there as well. And I think that mineralization is one of the key factors that the cement industry is really looking forward to apply as a volume feeder to and replacement of cement, Portland, for example. But also what we see is how the partnerships with other companies will go through. And those concepts have to be standardized, but I think that we are currently not yet in that mature phase in terms of the applications or the actual storage to fully understand, what are going to be the different opportunities. It is more of a chicken and egg problem, because basically you need that availability of CO2 as a feedstock to make companies apply solutions with CO2. So what we see is that in the following years, there's going to be an exponential growth that we still haven't identified as a possibility to utilize with CO2. But I'm very, very certain that in the next, by 2025, we're going to have a much better understanding on the economies of the actual utilization or ways of storing CO2 in a different fashion. That's what we're having right now.
Yeah. So thank you for your comments, both of you, on mineralization, and a good advertisement for our session at 2:50 this afternoon, which is going to be asking the question of whether we can get to a net zero concrete, and the issues we're talking about, or the potential ways of getting there, are to do with, of course, mineralization. We have another question here from Dali Bondar, and he asks, any idea on what can be the percentage of CO2 captured by clinker in cement compared to other applications, and is there drawbacks for clinker properties, or let's say limitation for that? I'm not quite sure what this is referring to. So when we talk about, sorry, go ahead, Eberhart, if you feel able to answer.
Yes, I think this is for us a typical question. I think that I understand what he's trying to ask. Mm-hmm. And what is he asking is that what is the recovery yield? What is the carbon capture rate of the technology? And if it has a difference between the cement industry and others? I would say it's not. I think it's mostly just a technical design of the unit. It is a combination between the budget that is given for a project, together with also the ability of capturing CO2 at 80%, 90%, or 99%. It's just basically what is the options. And from at least from the chemical absorption point of view, that makes not a very big difference in terms of the ability of a system to capture CO2. It's more about the expense that you will need to have, the capital expense for increasing your design to capture that amount and rate. But there's no disadvantage between the cement industry and other industries. Actually, I see through the high concentration of CO2 in the flue gases, talking about above 14%, it goes between 11 to 22%. I see there, an advantage towards, for example, gas turbines, where they have a very diluted CO2, and they will need to work more into the oxy-fuel or on the oxy concepts.
Yeah, Dali, just to clarify though, the CO2 is not being captured by the clinker, it's the clinker that's emitting the CO2. And so there's no impact at all on clinker properties. I have one final question I wanted to ask you. I was reading an article in the newspaper yesterday about some of the challenges at the Guloren CCS project. And these were challenges with the geology in terms of storage. And some of the delays in the project were put down to issues that had occurred that hadn't been anticipated there. I just wondered if any of you had any comments on whether the challenges of specific storage locations are adequately understood. And Guloren, maybe I could ask you that question first.
And indeed, Gorgon has been having some challenges. Gorgon, in terms of storage, is using what we call dedicated storage. It's a saline aquifer. And when we look at, as Daniel referred to it, a lot of the existing facilities in the CCS space have been using enhanced oil recovery, i.e. Putting CO2 down into oil and gas reservoirs, oil reservoirs basically, or kind of they're able to use depleted oil and gas reservoirs. And of course, we understand oil and gas reservoirs better because we've done a lot of drilling and seismic, et cetera, monitoring of that. When it comes to saline aquifers, there are huge amounts of them and sort of more than enough globally, dispersed globally, to meet our sort of storage needs. But aside from CCS, they haven't had any commercial value so far. Therefore, we do not know necessarily, and we haven't undertaken enough characterization and analysis to understand what those characteristics are. And in order to develop them, we will need to ramp up again, similar to oil and gas industry characterization of oil and gas fields of 1P, 2P, 3P. I think we'll need to kind of ramp that effort up in order to better understand and characterize these resources, which we'll need to develop in parallel with capture.
Yep, if I may add, in parallel and in advance of, so as Edward was saying about chicken and egg, saline aquifers can take 10 years to develop, but these are big national infrastructure, but that they are wonderful opportunities for a nation to actually exploit. Norway's doing that. They see a market and being able to take European CO2. They've had that with oil and gas. They're seeing this with aquifers and actually being able to store CO2. And it does just take time. It's for our geologists collectively to actually start working on that, because that's just a great way at very frankly low cost that governments can actually support this and enable massive unavoidable industrial decarbonisation by actually exploring those natural resources that they've got.
Completely
okay, well,
agree.
thank you, Daniel.
I've been shaking my head because completely agree with Daniel.
Okay, thank you, Daniel. Thank you, Guloren. And thank you, Eberhart. That really brings us to the end of our time. So thank you to all of the panelists, and thank you for your questions. And I hope you found the session informative. Goodbye.
See you then. Thank you very much.